This is the presenter about this presentation.
Assalamualaikum and good day to Madam. My name is Dayana binti Abdul Razak and my matrix number is D0120101447.
Assalamualaikum to Madam. My name is Farah Dina binti Muhammad KHAIRUL. My matric number is D0120101127.
My name is NURUL HAZWANI HUSNA binti Shahrizal. My matrix number D0120100072.
Assalamualaikum to Madam. My name is Farah Dina. Today I will be present an introduction. AC circuit, namely alternating current, is an electric current which periodically reverse direction and it can change the magnitude continuously with time to direct current, which is DC. So it means it is a voltage or a current that where the signal changes sign. The waveform is sinusoidal waveform. Sometimes it is a positive and negative side. All DC based plug-in rechargeable battery-based device technically operate based on an alternating current. So what is the difference between DC and AC? Which is also the basis of the reverse characteristic. The difference between DC and AC is the comparison base of frequency. For DC, the frequency is 0, and the AC, we use the 50 or 60 Hz. Next, the base of current in DC, the constant magnitude, and AC, the magnitude is vary with time. And then the direction of DC is steady constant, flow in one direction, and the direction of AC is reverse direction periodically when flowing through a circuit. And then the comparison of the waveform is the DC is straight line, and then the sinusoidal for AC circuit. And the last one is the parameter used. In DC we use only resistance, and the AC circuit we use dependence, which is RL, RC, and RLC. This is the circuit we simulate in PSpice. So for the right side, this is the setting of V sign, and we use DC, AC, V off, TD and DF is equal to 0, and then we use VMs equal to 13.5, and the frequency is 50 Hz. And the last one is phase, we use and negative 90. For this assignment, we need to find the value of inductor and capacitor first, because the value of inductors and capacitors is an impedance. So when we simulate circuit in PSpice, we have to use in which units Henry and Farah. So first of all, we assume the value of Hertz is 50 Hertz, and we have to find the value of omega is equal to 2 pi frequency, and we get 314.4. So next, we need to find the capacitor value using the formula 1 per j omega c, and replace omega with 314.2, and then we get the capacitor value of 0.04456 Farad. Second, we need to find the inductor value using the J50 is equal to j omega c formula. As usual, we replace omega with its value and look for value for inductors. We can define inductor is equal to 0.0159 Henry, and the last one is to find the current source. We need to find the RA value first to get simple circuit, and the formula used is RA is equal to 20 minus J 0.0715 multiplied by 4 plus J 4.99 divided by 20 minus 3, 0.0715 plus 4 plus J, 4.99, and we plus 10, and the last answer is we have 14.028 plus J 3.321. And the second part, we must to show you the simulation and calculation for my assignment. For the first, we need to find the current source value first. Then we can find the next current, which is the current of RL load, and also the current for RC load. In the simulation, we found the IP we plotted was the highest peak, and we found that IS is equal to 2.45 amperes. To determine the answer in the simulation was right or wrong, we need to make a calculation using the formula. IS is equal to VS divided by ZS, and we get 25 ampere. Negative 90 degree divided by 10 is equal to 2.5 ampere. Negative 90 degree. The second is current RL. We need to find the current in the RL section as well before we get the voltage value for each load. In the simulation, we have plotted at the highest speed, and the value for our simulation is 1.97 ampere, while the value for calculation is almost exactly is equal to 1.815, negative 0.14 degree, using the formula which is IRL is equal to total RA divided by 4 plus J 4.99 plus total RA, and multiply by IS, and we get this answer. Next is the current RC. At the time we got the value was IRC is equal to 0.194 ampere, and at the same time it was more similar, but the range between 0.1 to 0.3 also, and the value of the calculation is 0.806, negative 63.45 degree. Using IRC is equal to IS multiplied by IRL. For 10 ohm voltage, we plot on peak voltage, and the value for the simulation was 24.48, and when they calculate use the law of Ohm's law, the value was 25, negative 19 degree volt. It almost the same, and it not accurate. Maybe the reading we plotted there was a little wrong. For 4 ohms voltage, where we got 7.96 volt, and the graph we got was a graph cost. At the same time, we got 7.26, negative 101.43 degree. For 5 ohms voltage, where we got 3.21 volt, and at the same time we got 4.03, negative 63.336 degree in calculation. For 15 ohms, the highest peak we could plot was 9.64, and make that value for 15 ohms. Whereas when we're doing it, the value is a bit far off, which is 12.09, negative 63.336 degree, and this is likely to change quite a bit because of the availability of a capacitor with 15 ohms. Second last is voltage for inductor. What we know, in order to find the voltage value of the inductor, we need to use the J omega Li formula. In simulation result, we found that the value of voltage for inductor is 9.87 volt, where for calculation using J omega Li formula, and we got the answer is 9.067. And the last one was voltage for capacitor. For capacitor also we got a cost graph, and the value for simulation result is 0.045 volt. While in calculation we use a 1 divided by J omega C formula for capacitor voltage, and the answer to calculation is 0.0571 negative 153.45 volt.
Assalamualaikum and good day to madam. So I will continue for the part calculation of apparent power, reactive power, real power and power factor. So this is the step to produce the apparent power, power factor, real power, and the last one, reactive power. At first, we need to find the value of VRMS, and we use the formula stated here, which is V divided root of 2. Then we get 17.677 volt. Then we apply the formula of IRMS, which is I divided root of 2. Then we get the answer 1.7677 ampere. From both value, we get the S, which is apparent power, 31.25 volt. So to find the real power and reactive power, at first we need to find the power factor. Then we get the theta for the power factor is 0. So the real power factor we get is 1. Then we substitute the value of power factor, which is 1, into the formula of real power, P equal to S cos theta. Then we get 31.25 volt. Then the last one, for the reactive power, the formula stated as Q equal to S sin theta. Then we get the answer 0 VAR. So next, I will continue for the part of sketching the power triangle of P, Q, and S, and the phasor diagram of voltage and current source. So this is our power triangle of the circuit, and we have apparent power, reactive power, and the last one is real power. So the value of apparent power that we get is 31.25 volt. For the real power is 31.25 watt, and the last one for the reactive power is 0 VAR. So this is our sketching for the phasor diagram of voltage and current source. So this is our sketching, and we have imaginary axis and real axis. So at the imaginary axis, we have the value of Vm, which is 25 volt, and the theta is minus 19 degree. So at the real axis, we have Im volt value, which is 2.5 ampere, and the theta is also minus 90 degree. So we have made some calculation to find the Vm and IM value. So this is our calculations, and we use the formula of PM is VRMS multiply root of 2, and we get the answer almost 25 volt. So next for the IM, we use the formula as IRMS multiply root of 2, then we get the almost the same answer, around 2.5 ampere. So that's all from me, and I will pass to the next member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL HUSNA. So I will explain about the discussion. The goal of this project is to investigate alternating current circuits by evaluating resistance, inductance and capacitance when the frequency of the input voltage is changed. We built numerous circuits using various resistors, capacitors, and inductors, as well as changing the frequency to investigate how these variables impact capacitive and inductive reactance values. As can be seen, the simulation and calculation results have approximate value between them. This is because there is some error when doing the simulation, and the plotting technique also required to do the simulation. Thus, it will display an exact figure, whereas the computation will deviate in decimal places, and the circuit could be more complex to be solved. We also measured the peak of the waveform to get the value. For resistor, one inductor, one AC voltage source, and one capacitor are utilized. To solve the AC circuit analysis, we applied the source transformation approach. In the frequency domain, source transformation refers to the conversion of a voltage source in series with an impedance to a current source in parallel with an impedance, or conversely. The formula that is used is as shown in the slide. Next, we need to find the apparent power, which is S, real power, which is P, and the reactive power, which is Q, for the whole circuit. To find apparent power, the formula is as given: VRMS multiplied by IRMS. For the apparent power is the product of the RMS values of voltage and current. The apparent value from the circuit is 31.25 volt. To find the real power, which is P, we need to find power factor first. To find the power factor, we use P over S, or equals to cos theta voltage minus theta current. The angle theta voltage minus theta current is called the power factor angle because it is the angle whose cosine is the power factor. So the power factor value from the circuit is 1. Then we can find the real power, which is P, equals to S cos multiplied by theta voltage minus theta current. The real power, which is P, value from the circuit is 31.25 watt. The real power, which is P, is the average power in watts delivered to a load, and it is the actual power dissipated by the load. Lastly, to find the reactive power, which is Q, equals to S sin multiplied by theta voltage minus theta current. So the reactive power, which is Q in the circuit, is 0 VAR. The reactive power Q is a measure of the energy exchange between the source and the reactive part of the load. The unit of Q is the volt ampere reactive, which is VAR. To distinguish it distinguish it from the real power whose unit is the watt. Next, I will explain about the phasor diagram of voltage and current. The apparent power, real power, reactive power and power factor angle are the four components of the power triangle. We have an inductive load and a lagging power factor. When S is in the first quadrant, the load is capacitive and the PF is leading when S is in the fourth quadrant. The complex power might be also found in the second or third quadrant. This necessitates a negative resistant load impedance which is attainable with active circuits. For the circuit that we build, the explanation is S is in the first quadrant of the phasor diagram for the circuit that has been built, with Vm equal to 25 volt and Im equal to 2.5 ampere. For the conclusion, a graphical depiction of the relationship between voltage, current and power is an alternating current power analysis. Multiplying the RMS values of current and voltage yields the average AC power. Divide the RMS voltage by the impedance to obtain Ohm's law for RMS AC. In an AC circuit, the source voltage and current have a phase angle which can be calculated by dividing the resistance by the impedance. The phase angle has an impact on the average power provided to an RLC circuit. The power factor might be anything between -1 and 1.